So in this example, we have fn is 0 if n is 0, fn is 1 if n is 1, and if fn is larger than 2, it will be the two place before plus 1. So let's have a simple analysis. So n is 0, we have 0. N is 1, we have 1. N is 2, it will be what? F0 plus 1, it will be 1. So F0 is 0, right? And then what? F3, it will be F1 plus 1, it will be 2, okay? F4, it will be F2 plus 1, it will be 2, and so on. We will proceed with a generating function. So first, assume fx is a power series, that is f0 plus f1 x1, so on. Now, we have a red box. So what is the red box? The red box is that we have a 1 here. We try to link the fn and the fn minus 2 and express it as a constant 1. So we try to create the subtraction of fn minus 2. So how do we do that? Here, we see that fx is this sequence. So if we multiply fx by negative x squared, we are raising everything by power 2. So we will get f0 times x squared minus f1 times x cubed minus, and we'll get this. Again, there's a 1 here, so we're going to do what? Addition. So this one, add the negative x squared f, give us the thing in the bottom, this term. What about this term? We're going to do addition. So this guy come down, this guy come down, and then for the x squared term, we see that it is f2 minus f0. So for the x squared term, it's f2 minus f0. For the x cubed term, it's f3 minus f1. f3 minus f1. So we now have this one. What's next? What are these? What are these? By the red box, this is 1. This is 1. Okay? So for the x squared term, we have a 1. For the x cubed, we have a 1. Okay? And so on. For the blue term, it's 0 because n is 0. The yellow term, f1, is 1. Okay? So there's a 1 here. So now we have this thing equal to this thing. Then what's next? We move the 1 minus x squared divided. Okay? So now here is some simplification. X 1 plus x squared plus so on, right? This is basically what I'm doing. Factor out the common x. And then what's next? This is x 1 minus x, right? So this bracketed term, now I just replace r by x, so I get this. Now I move this to the other side, so that means I divide this by the yellow term. So that gives me this guy. So now we are at here. What we need to do? Partial fraction. So this is now a complicated partial fraction. So let me do it step by step. We want to find an ABC. So this thing, okay, is the same as. So what I'm doing is I multiply that whole thing by the denominator. So here, I cancel out everything. So this part, I only have x left, which is this x. This part, I multiply the whole thing by this product. I will cancel out each of the specific terms. So for this part, this 1 plus x cancel with this one, so I have the 1 minus x squared here. For the b, I will cancel out with one of the 1 minus x, so I will get this, and same for the c. Then what's next? I will plug in specific value of x to get my ABC. So from here, if x is 1, then I will get 1 equal to 0 plus 0 plus 2c. If I put x is 1, this is 1, this is 1, 1 minus 1, 0, gone. This is 1 minus 1, 0, so gone. This one is 2, so I have 2c. So c is half, okay? So c is half. Now we proceed with other x. So we can say, let's say x is 0. So if x is 0, then we will have 0 equal to a plus b plus half, okay? So that means we have a relationship between a and b. Next, let's say x is -1, then -1 equal to a4 plus 0, 0. So a is -1/4. So how do we get this? If x is -1, this is -1, so this is the -1. X is -1, so we have 2 squared, so that's why we have 4. If x is -1, this gives us 0. This guy died, so we have this thing. So therefore, a is -1/4, okay? And with this in mind, we can go back here. So if a is -1/4, will give us 0, then b will be -1/2 plus 1/4. That means also -1/4. So we now know a and b are both -1/4. So we get a -1/4, b -1/4, c half. This corresponds to this a, b, and c. So we get this. So now we are at here. So at here, so what I'm going to do is I try to use the infinite series. So remember, I have 1 minus r. This is minus, negative, okay? But here, this is positive. So what I'm going to do, I'm going to make it negative by adding a bracket. So this is what I do. For this part, no change. Okay? And lastly, for this guy, I do this. Again, this is not so trivial. Let me explain. So I want to differentiate this guy, so I can write this as this term. So I basically write the power here, and then I can perform chain rule. So I put this term and this term here. So this one and this one is basically I throw the power here, and then 9 minus the power. And then this one is basically -1. So this -1 and this -1 cancel out. So I have this term, which I can write like this. So this is saying this term is same as this term. So now we are looking at this line. So we have this in mind. So what's next? Well, this is just an infinite power series. This is just the ordinary power series. This is just the power series. And this one, we need to differentiate the derivative inside. So if we take the derivative, this one will be gone, this one become 1, this can become 2x power 1, and so on. So the 1 go to here, 2x power 1 go to here, and then there will be 3x squared here, and so on. So this is the yellow bracket. And what about the other bracket? We keep them. So we have this term. So now we are looking at this line. So what's next? Well, we have a bunch of numbers. So we compute the sum correspond to a different power. The first thing is we look at the power 0 term. So it will be this guy multiply the 1 plus this guy multiply the 1 and this guy multiply the 1. So it will give us negative 1 over 4. Here is also negative 1 over 4. This one is just half. So this is the first bracket. And then we will be looking at the power 1 term. So it will be x to the power 1. So this guy will be x to the power 1 multiply the negative 1. But there's a negative sign. So therefore, this is the positive 1. And then for this guy, this is the x power 1. We will be looking at the negative 1 over 4. So we have this negative 1 over 4. And then for this guy, there will be 2x. But it will be divided by 2. So therefore, it's 2 divided by 2. So this is the power 1 term. And similarly, we can look for the power 2 term. Okay, it will be this. Now we are at this line, so we can now proceed to find a general pattern. So for the first term is everything with x to the power 0. So we can think of the first negative 1 is basically 0 plus 1. That means power 0 plus 1. And then the second one, negative 1, will be just stay there. And then this 1 over 2, after we factorize the sum, after we take the common denominator, so it will be 2 times 0 plus 1. Okay, so this will be the first term. And then if we're looking at the second term, is x to the power 1. So we can think of it as this is negative 1 x to the power 1. And the same thing for the negative 1, it keeps the same. And then we have this, if we take the common denominator 4. And lastly, we can have the x squared. So we will see the pattern here. Okay, so that means what? That means we find a common pattern. Fn is this thing. Okay, so to check whether or not this is true or not, we can use mathematical induction. But in this course, this time we do not do anything on mathematical induction. So we will just put some n value to check is it true. So suppose n is 0, we should get Fn is 0. So let's see, if n is 0, we will get 0 plus 1 minus 1 divided by 4, which is 0 divided by 4 is 0. So n is 0 case is true. So suppose n is 1, 2 plus 1 minus squared divided by 4. So it will be 2 plus 1 divided by 4, that is 1. So n is 2, we will get 4 plus 1 minus negative 1, 3 divided by 4, it will be 5 minus 1 divided by 4, which is 1. N is 3, it will be 6 plus 1 divided by 4, which is 8 divided by 4, which is 2. True. Okay, and so on. So this is correct.